Welcome back. The last class we had seen the configurations, common source with RS, CD with RD, and we calculated all voltage gains. Now let's calculate output impedances, okay, for all four configurations. Okay, now output impedances. Number one, CS with RS amplifier. Then take RS 0, then you will get CS amplifier. Easy, okay? CS with RS amplifier. First of all, don't write, listen. This is RD, RS, VDD, and this is what is your output voltage V0, and this is input voltage Vi. Okay, this is drain, gate, source. Now, what is the definition of output impedance? Just to have output impedance definition for your understanding purpose, let us consider AC circuit. AC circuit. Okay, what is AC circuit? The MOSFET should be replaced with the equivalent circuit, but already we have that, but let me define with respect to keeping the transistor as it is. Then, right, this is nothing but your RS, whatever you have here, and this is Vi. Okay, now tell me, for AC analysis, this VDD is connected to ground. Then this RD is coming in parallel to your output, right? Therefore, this RD is coming in parallel to your output. This is the load, okay? This is AC ground. Basically, this is your AC ground. What it may be, and this is what is your V0, and this is a drain, source, gate, right? And this is what is your amplifier with respect to load, right? This is with respect to load. Therefore, tell me what is output impedance definition. The definition of output impedance is nothing but the impedance seen from output port. The impedance seen from output port. Exclude the load. First of all, we need to exclude the load. Exclude the load. The impedance seen from output port, right? When Vi is equal to 0. Because I told you already the definition, right? Exclude the load, apply the voltage, get the current. That current should be because of the applied voltage, not because of anything else. Means we have to make Vi 0. If Vi is 0, then the output current is not because of input. The output current is because of applied output voltage what you get. Then output voltage divided by output current, you will get output impedance. Because this is a dynamic resistance, therefore dynamic voltage by dynamic current, that is what we need to have. Okay, that is fine. Therefore, exclude the load, the impedance seen from output port when Vi is equal to 0. Can I say that is what your output impedance? Fine. Now, what we need to do, actually if you take any textbook, right, the MOSFET will be replaced with the equivalent circuit. Then Vi, take Vi is equal to 0, apply some AC voltage, get AC current, AC voltage by AC current, output impedance. With that also we can do, right? KVL, KCL, etc. Now, let me explain in a different way. That is easy to understand. Okay, the definition, if you know the definition, very simple. Impedance seen into output port when Vi is equal to 0. Now, can I write this black box, whatever black box you have, right, with respect to the load? Therefore, what is V0? We know that V0 divided by Vi is equal to, this is CS with RS amplifier, right? What is that? Not derived formula, original formula. Derived formula is that minus RD by RS, which is stable. But I want original formula. minus mu into RD divided by capital RD plus small RD plus 1 plus mu into RS. This is what is our, then tell me what is V naught. Then V naught is equal to, Vi minus mu into Vi into RD divided by capital RD plus small RD plus 1 plus mu into RS. Can I write like this? Just Vi, I took it to right hand side, minus mu into Vi into RD divided by RD plus something. If you observe clearly, it is like what? V naught is equal to some input source into RD divided by R1 divided by R1 plus R2. Voltage divider network, right? Therefore, can I replace or can I equivalently represent? Therefore, indirectly I am replacing the black box with this. Therefore, this is V naught across RD. V naught across RD with the source of this. Then if I write, then can I write it like this? Kind of modeling. This is minus mu into Vi. Then this is basically RD and this is small RD plus 1 plus mu into RS. Okay. Now this is what is our, this is output impedance. If you observe clearly, therefore tell me, if you treat this like R1, R2 and then V, then R1 divided by R1 plus R2 into this, that is nothing but your output voltage, right? Therefore, this is what is your output voltage. This is output voltage. Then tell me, what is output impedance definition? Exclude the load. Exclude the load. Impedance seen into output port. Impedance seen into output port. When VA is equal to 0, when VA is equal to 0, that is left with what? This one only, right? Simple. Therefore, this is what is our R0. Therefore, what is R0? R0 is nothing but simply, because when we have to make VA 0, when VA is 0, then it is small RD plus 1 plus mu into RS. This is what is your R0. Got it? This is easy, right? Just kind of modeling, mathematical modeling to get equivalent representation. Okay? Take this. And in this, if you substitute capital RS is equal to 0, then you will get CS amplifier output impedance. Okay? You take it, then we will see the next one. Next one is CS amplifier. I will give you 1 more minute to complete. Try to complete before that. Then we will see the second one. The people who have completed already, then they can do the second one. Common source amplifier. Just represent the circuit, then you will get it R0. Okay? Your own way. Then I will see, or we will write on the board. Not we, I will write. Over? Done. Now, let's see the second one, common source amplifier. Okay? Listen. CS amplifier. What is the circuit? This is what is the circuit. This is the input and this is the output. VDD, RD. Right? This is drain, source, gate. Now if you see here, this is what is AC circuit. If you take AC circuit, this is what is ground, and this is what is your input voltage. Okay, then this is what is your, therefore what is output impedance? Again, exclude the load, the impedance seen into output port when Vi is equal to 0. We already did it, right? This is nothing but output impedance of CS with RS amplifier, CS with RS amplifier when capital RS is 0, when capital RS is 0, right? Therefore, what is that? R0 is equal to small rd plus 1 plus mu into RS when RS is 0. When RS is 0, what is R0? R0 is simply small rd. Okay, therefore the output impedance is nothing but small rd. That is what it is. Take it. After this, the third one, CD with RD amplifier. Maybe that you can try. Can you try to find output impedance? Similarly, CS with RS amplifier. Similar to CS with RS amplifier, CD with RD amplifier. After this, okay, I'll give you 1 minute to complete. You try to complete before that. Then we will see the third one, CD with RD amplifier. It is not important, it is impedance. Okay, I hope you know that. Over. Now write down third one, CD with RD amplifier. CD with RD amplifier. Circuit is this is RS, RD, VDD, this is your V0, right? Drain, source, gate. Now, let me write AC circuit. What is AC circuit? That is easy to find the R0 definition, or we need to incorporate the R0 definition. Now, if you write that, this is what is your RD. Now, this is the load, right? Can I extend the load to right hand side? We can extend it, right? Yes. If I extend the load to right hand side, this is what is the load, RS, and this is V0, this is RD, and this is what is connected to AC ground. Okay, and this is what is your input, the small signal input, right? And now this is what is your black box with respect to load, right? With respect to load, this is what is your load, right? This is drain, source, gate. Therefore, what is output impedance definition? Output impedance definition is nothing but the impedance seen into output port, the impedance seen into output port when Vi is equal to 0. Therefore, exclude the load, the impedance seen into output port when Vi is equal to 0. That is what your output impedance, right? Therefore, again, can we write it like this? We know that V0 by Vi. What is voltage gain? Original formula. Mu into Rs divided by capital RD plus small rd plus 1 plus mu into Rs. Right? Now, again, can I write it like this? V0 is equal to mu into Vi into Rs divided by capital RD plus small rd plus 1 plus mu into Rs. Can I write it like voltage divider network? Like mu into Vi, Rs divided by Rs plus something, but Rs is having some coefficient which is 1 plus mu. Therefore, I cannot write it like voltage division network. But Rs is my load. I want to exclude the load and I want to find V0 with respect to Rs only. Therefore, I want separate Rs to the denominator. Then what to do? To get only Rs, can I divide it by 1 plus mu? Both numerator and denominator, then this term will become only Rs. Okay? If I do that, therefore what is your V0? If I divide by both numerator and denominator, that will be equal to mu divided by 1 plus mu into Vi into Rs divided by capital RD plus small rd divided by 1 plus mu plus Rs. Therefore, can I write like this? Therefore, this is nothing but what? V0 is equal to some voltage into R2 divided by R2 plus R1. Voltage divider network. Therefore, using this model or using this equation, can I write the black box equivalently like this? Mu into Vi divided by 1 plus mu this is nothing but Rs and this is your V0 and this is capital RD plus small rd divided by 1 plus mu. This is what is your black box. Now the black box is equivalently represented with using this equation, right? Therefore, what is the R0 definition? Exclude the load, the impedance seen into output port when Vi is equal to 0. The impedance seen into output port when Vi is equal to 0. Therefore, what is that? When Vi is equal to 0, this is short circuit. Then impedance seen is nothing but what? Therefore, R0 is equal to capital RD plus small rd divided by 1 plus mu. R0 is equal to capital RD plus small rd divided by 1 plus mu. Okay, this is what is your output impedance. Take it. Then the fourth one, CD amplifier. Then you have to take small capital RD is equal to 0. You take capital RD is equal to 0. That is what is your output impedance. Okay. After completion of this, you try to write the fourth one also on your own, and we will see the observation part. With this, I can say all 4 configurations, voltage gains as well as output impedances, they are over except one configuration, that is common gate amplifier, which we will see after this. Okay. After third, you write fourth one, CD amplifier, right? Over after this, write down the fourth one. You are finding all these things easy, right? Because mostly depending on network analysis. That's why we feel them easy, because networks are interesting and then easier if you understand the methodology and the flow. Now the last one, CD amplifier. The last one, CD amplifier. This is VDD and this is a drain. Okay. Now for AC analysis, the drain is connected to AC ground. Now tell me, what is your output impedance definition? Exclude the load, then make Vi 0. The impedance seen into output port when Vi is 0. That is what the output impedance, right? We already calculated. We can use it. Use whatever existing. Therefore, R0 is nothing but output impedance of CD with RD. CD with RD amplifier when RD is equal to 0. When RD is equal to 0. Therefore, what is output impedance here? The impedance seen into source. The impedance seen into source. That is nothing but your CD amplifier output impedance. In the case of BJT, what is this? In the case of BJT, this is nothing but CC amplifier output impedance. Okay, what else may be? Tell me what is R0 now? Therefore, R0 is equal to CD with RD. Capital RD plus small RD divided by 1 plus mu. Now you need to substitute capital RD is equal to 0. When you substitute capital RD is equal to 0, then what is your R0? R0 will be equal to small RD divided by 1 plus mu. Can I treat 1 plus mu as mu? Because mu is very much greater than 1. Therefore, this is approximately RD divided by mu. Since mu is greater than 1. 30 also or more than 10, that you can take it as greater than 1. Then what is mu? We know that mu is nothing but amplification factor, the transistor intrinsic gain. Therefore, that is nothing but Gm into small RD. Then if you substitute, therefore, what is your R0? Your R0 is RD divided by Gm into RD. RD will be cancelled. Then your R0 is nothing but 1 by Gm. Therefore, what is R0? 1 by Gm. You remember, I told in the case of BJT, right? The CC amplifier, the impedance seen into emitter. In the case of MOSFET, this is source, but in the case of BJT, emitter. Impedance seen into emitter is nothing but 1 by Gm, and we know Gm is nothing but IC by VT in the case of BJT, which is nothing but VT by IC. That time, one of the problems, small RE is given, which is 25 millivolt divided by IC, IE. You remember? That is what it is. Therefore, R0 is equal to 1 by Gm. And I derived from H parameter model also. That time, we got approximately 1 by Gm. Okay, fine. Take it. With this, I can say all 4 configurations are over. Okay. Then let's complete the 5th one. Then I'll give you the summary. I'll give you the table with all configurations related to MOSFET. Then we'll see the observations with respect to the table. Okay. What are all the observations we had seen in the case of BJT? Similar observations, or I can say same observations we are going to see in the case of MOSFET. I'll give you 1 minute time. Try to complete. Done? Okay. Write down the last configuration. With that, I can say MOSFET small signal AC analysis is over. Fifth one, CG amplifier. Don't write, listen. Therefore, let me give you a CG amplifier. What is this in the case of BJT? Common base amplifier. Here I am going to take practical voltage source because input is not at gate. If input is at gate current is 0, but input is at source. There is a current, there is a drop, therefore we need to consider practical voltage source. This is your Vs, Rs, whatever may be, this is what is your input voltage, the core transistor voltage gain, right? Now gate is connected, AC ground, and this is the load. This is what is your, let us say RD, and this is your V0, drain, source, gate. Okay, this is what is your common gate amplifier. Okay, now let's see. Here input current is there. Okay, the current which is what is entering into your input, let us say this is what is your I1. Okay, maybe let me, okay, and the current which is what is entering into the load is nothing but your IL. This is with respect to load. The current which is entering into the load is nothing but IL. This is with respect to input port. The current which is entering into your input of amplifier is nothing but I1. But let's see the real current flows with respect to the MOSFET current directions. The real current is nothing but what? The real current is nothing but the current which is entering into drain. This is what your real current, which is nothing but ID. Therefore, what is IL? IL is nothing but minus ID. Similarly, the current which is coming out of the source, that is nothing but your ID only. ID only, the same current is coming out, right? Because gate current is equal to 0, whatever current which is entering into drain, the same current is coming out of source. Then what is your I1? I1 is equal to opposite to ID, therefore minus ID. Actually the current which is coming out of source, but according to two-port network analysis or amplifier parameters, current which is entering into your amplifier is nothing but your I1. Okay? Similarly, the current which is entering into load is nothing but IL, which is opposite to the real current flow, right? Now, in this case, remember, we need to calculate all 4 AC parameters. Input impedance is not infinity because input is not at gate. Only gate current is 0, not drain current, not source current. And current gain is defined because input current is there, output current is there. Therefore, we need to calculate all 4 AC parameters for the common gate amplifier. Okay? Write this. Now, let's calculate all 4 AC parameters: current gain, input impedance, output impedance, and voltage gain. Okay? Take it. Okay, now listen, don't write anything. The first one, the first AC parameter, current gain. What is current gain definition? The current which is what is entering into the load, that is IL, and the current which is what is entering into input of amplifier. Therefore, what is that? I1. This is what is with respect to current gain definition. Then let's see what is the real current flows. What is IL? Minus ID. What is I1? Minus ID. Therefore, what is current gain? Absolutely 1, not approximately equal to 1. It is absolutely equal to 1. But in the case of BJT, common gate amplifier, your current gain is approximately equal to 1. Close to 1, but approximately equal to 1. This is absolutely 1. Because whatever current which is what is entering into drain, the same current is coming out of source. Therefore, your channel current is common only. Now, the second one, we can calculate directly voltage gain. Okay. Okay, voltage gain we will see the last. Now let's see the input impedance part. Okay, what is input impedance definition? the impedance seen into input port, right? What is input impedance definition? The impedance seen into input port. Let us say this is what is my input port, the impedance seen into input port. Therefore, what does it mean? The impedance seen into source when gate is connected to ground, drain is connected to RD and ground. That is nothing but your input impedance, right? Similarly, what is output impedance? Exclude the load, the impedance seen into output port when Vs is equal to 0, right? That is what your output impedance. That is the definition. Actually, if you take any textbook, how they calculate Ra and R0, they replace the MOSFET with equivalent circuit what I gave, then apply the input voltage, get the input current, take the ratio, that is what is your Vi, right? Similarly, how will you find R0? Exclude the load, apply the voltage, get the current, after making Vs is equal to 0, then take the ratio, you'll get R0. But I will not do all those things because redundant, which we already calculated actually, if you see that, okay? That is what I want to explain. In this session, let me explain that, at least Ri, then in the next session we will see R0 and voltage gain. With that, CZ amplifier is also over. Just listen. Now, what is input impedance? For the second one, input impedance, right? Which is nothing but the Vi divided by I1. Okay, instead of calculating with respect to ratio of Vi and I1, I know that the impedance seen into source when gate is connected to ground, drain is connected to RD and ground, right? Let us consider CD with RD amplifier. CD with RD amplifier. If you consider CD with RD amplifier, what is that? That is nothing but this is CD with RD amplifier. This is source, drain, gate, this is your V0, right? Then what is AC circuit? AC circuit means what is your output impedance? Therefore, if you write AC circuit, what is AC circuit? You will see this is your RS and V0, this is Vi, and this is source, drain, and this is RD, this is VDD, right? Now if you take AC circuit, then we already defined output impedance. What is output impedance definition? Exclude the load, the impedance seen into output port when Vi is equal to 0. When I say Vi is equal to 0, your gate is connected to ground and drain actually AC ground, right? For AC circuit, this is also connected to ground, AC ground, right? Now tell me, what is output impedance of CD with RD amplifier? Exclude the load, impedance seen into source when gate is connected to ground, drain is connected to RD and ground. What is input impedance of CZ amplifier? Impedance seen into source, when gate is connected to ground, we have to make Vi 0 for R0, right? And drain is connected to RD and ground, same, right? Both are same, right? Therefore, what is Ri? Ri is nothing but your common gate amplifier. Therefore, Ri is nothing but output impedance of, I don't have space here to write, okay? But it's better if you write here, okay? Output impedance of CD with RD amplifier. What is that? That is nothing but capital RD plus small rd divided by 1 plus mu. This is what is Ri. No need to calculate because we already calculated it. Let's use it, okay? Take it. Similarly, if the people who have completed the second one, just think about R0. How to, that is also redundant. No need to calculate by replacing the MOSFET with the equivalent circuit and then do V by I when Vs is 0. Because that is already there, which we have seen before. try to correlate to the existing one, then tell me what is R0 of CZ amplifier. Okay, you take this first. I'll give you 3 more minutes. I think within 3 minutes or 4 minutes, the session will be over. In this session, I can say current gain and input impedance, they are calculated. Next session, we will see R0, output impedance, and voltage gain, both. Then I can say CZ amplifier is done. Then MOSFET small signal AC analysis completely over. Okay? Write down.